Here is a tricky problem involving with tangents, but we'll see how applying again the simple formula and following a process we can solve this problem. So let's put again, just like the way other problems we solved, by writing down the information what we've been given. So here we have two circles. Let's call them C1 and C2. So inner circle is C1, outer circle is C2. So we have two circles and we have a tangent, let's call it AB, which is a tangent to an inner circle, and it cuts the outer circle at B. We have been given the length of AB as 1 inch. What we have to find out is the annular region, which is this area. So let's write first R1, which is the radius of the smaller circle, and let's write R2 is the radius of the bigger circle. So R2 means, and let's put this as center O, and let's put this as D. So OD is also R2. So let's put OD equal to R2. OA equal R1. We have AB equal 1. What we have to find out, and then we have also been given this one, is a right angle, because AB is a tangent. So that's the property of a tangent. So we have given OAB equal to 90 degree. So now by looking at it, it doesn't look like we have quite a direct way of finding the annular region. So we have to see how indirectly we can solve the problem. Now one thing is, you can take it as a thumb rule. Whenever you are given a tangent with it's cutting at a circle and the 90 degree, you are better off by drawing some sort of a triangle where you can apply a Pythagorean theorem. So let's write, let's put this, join this line, okay, AB. Okay, so now what we have to find out is the annular region. Now if you have solved already the problem annular region before, you would know the region, the area of that region is pi into R2 square, which is the bigger circle, R2, which is the minus pi R1 square. So we are really subtracting the smaller circle area, which is this, from the bigger circle area. So if you do that, then we'll be left with this area, so which is pretty easy to understand. And so this is what we have to find out. Now the problem is that we don't know R2 or we don't know R1, and what we've been given only AB, it's kind of not very easy to find out. But let's then figure out what else we know. Since we know that this is a Pythagorean theorem, then OB is the radius of the outer circle. So this is R2. So what we have is OB square in the triangle OBA. What we have is OB square plus OA square equals AB square. So OB square is R2 square plus R1 square equal 1 square equal 1. So I think we have made a mistake. OB square is the hypotenuse, so OB square equals to, well, let me rub it off. Let's rub the whole line. Let me write this one too. So again, I'm writing down here. What we have is, in triangle OBA, we have OB square equals to OA square plus AB square. This is OA square is OA is R1 square plus AB is 1 square is 1. So OB is again R2 square. So this is OB R2 square equals to 1 plus R1 square. So now let's look this one and this one carefully. Can we find out using this information? Can you find out this? Now if we see, it's almost like solving an equation involving two unknown variables, and we have two equations, so which you should be able to solve. So then if you take pi out of this, so you'll have R2 square minus R1 square. And if you look carefully, if you subtract R2 from both the sides, R1 square from both the sides, 1 plus R1 square minus R1 square equals to 1. So we have R2 square minus R1 square equal to 1, so which you can use it here. So pi times 1 equals pi. That's our answer. So let's recap quickly what we've got. We were asked to find out the annular region, and we first find out annular region is we subtracted the area of the inner circle from the outer circle, and then we applied the Pythagorean theorem to find an equations involving R1 and R2, which is this, and applied that to find out the area of the annular region. Thank you.